Okay, so look at this one here. So go ahead and sketch your FBD. So go and put your FBD picture here. Angle of 30-degree incline. Here's your object. There's your FG. You just gotta make sure that your FGX is parallel with that actual inclined plane. And this is your FG of Y. There you go. And then of course you got your Fn. Any other forces happening here? It says assume a negligible effect of friction and air resistance. So there's nothing in terms of friction, and I will put the net force here. So do you think that there could be an acceleration here? How would you know? Is there a net force in this question, or is it equal to 0? And how do we know? Well, just because there's an angle doesn't mean it's going to accelerate.
Because it's rolling down the hill. It's actually moving down. It's not going to be a net force of 0 because of the
friction is equal to 0. So if there's an angle here, what is going to cause that object to slide down? Exactly, the FG of X. This FG of X is going to cause it to slide down the incline. That is called the parallel force. Parallel with the inclined plane. That is going to make it slide down, not FG. Because FG always points to the center of the earth, straight down vertically into, like vertical on the page, right? So this is actually what's going to slide it. So if FGX is equal to the net force is actually not equal to 0. So net force has an MA, and acceleration is not equal to 0. So net force is not equal to 0. Okay? That's how you know. Okay, so you've got your FBD. So we have just again looked at parallel force. So what is parallel force? That is the one that is going to make the object slide down the incline. That's the job of the FG of X. Well, what is the job of the FG of Y?
The FG of Y is...
What is it doing?
The FG of Y is
It's pulling it to balance the F of N. The normal force. See this normal force right here? It is balanced by the FG of Y. The FG of Y is equal in magnitude to the normal force. It is not the same force. It just happens to be the same number. Okay? Just because something is the same number doesn't mean the same force. It's still different.
okay.
Just the surface pushing up on that box. It's called the F of N. So that FG of Y is the force coming from gravity. It's a fraction of gravity that is pulling down on that box that is perpendicular. This is called the perpendicular force. Okay? All right, so those are the jobs of that. Now it says determine the magnitude of the components. Just using trigonometry now. So the magnitude of the components in the FG of X and the FG of Y. So how do we figure that out? So that 30 degrees is right there. Okay? So the X is opposite over hypotenuse. So this will be FG. What's opposite and hypotenuse? Oh, sine theta. That's it. FGY would be FG adjacent over hypotenuse. Okay? All right, so that was just using trig. The last question here, it says the acceleration of the tire, so you know that it's going to accelerate down the incline. So then we go where to find that acceleration. Acceleration is net force equals MA. So if you're looking for acceleration, when you isolate this, divide this by M, divide this by M. Okay, acceleration is net force divided by the mass. But then you go, what is net force? Net force is MA, but that's what I'm solving for. What exactly is net force? Go back to your free body diagram, you see this net force right here? That is because of the Fg of x. That acceleration is due to the Fg of x.
So Fgx equals net force.
You got it. Okay, and because you've already calculated Fgx, which is Fg, which is mg, sine theta, that would be your net force. And you got everything there. You got your mass, g, 9.8, sine of 30 degrees. So you'll have that, and you divide it by the 2 kilograms. Done. Okay, I want to get into question 4 because that is similar to number 3, but you need to calculate the time. Okay, so let's just take a look at the other questions. You know how you have this, something like that, and then you have the other questions where it's just one question like that, okay, and then you have to actually solve for 5 different things in one question. You know how I like to break it down? I break it down into A, B, C, D, right? So that way your thinking is guided, but also be prepared. I might throw in a question where it's just one question like that, and you need to find things before you get to the actual question, like number 4. So let's take a look at number 4. As you read the question, as always, your strategy is identify what you know, right? You've got the mass, so I put M there. It slides down a ramp 15 meters long. So what is this? It says the distance, right? The ramp is inclined at 12, so we have the angle. If the coefficient of kinetic friction, so you know the mu, how long will it take? So I'm looking for time. If it starts from rest, what is that? Rest. V1. Okay, so those are the things that we know, and it does help the brain prepare for all the things that you need to find if you have it right in front of you. Looking for time, but before you do that, if you just sit there and you go, I'm looking for time, what equation do I use? This is gonna make your brain so hard, huh? What do you?
Find the time is 2 radical. Radical 2 d times distance.
See, that's not the strategy you should do, because you're looking at what equation should I use, right? Then you go, I've got my kinematic equation. You're looking at your equation sheet. You're looking at that. That's just a plug and chug way of doing things. When you're dealing with forces, what is the most reliable way to do this and to actually find your equation? What do you do?
Draw a diagram.
FBD, draw a diagram. So just draw a diagram. So you have a ramp. There's the ramp. You know this ramp is 15 meters long, right? You know that. But I'm gonna draw it so then I can get the equation from it. So this is 12 degrees. There you go. You have this equation. You've done this so many times, and again, I keep pushing you to do this. So you do this fast enough, and so you can do your equation from that FBD. What else is missing here? Friction, because mu is given, there's friction. And what else should I put? Net force going down. There you go. That is the most guaranteed way. And while your brain is starting to pick the equation to use, you're helping it out. So positive, positive, negative. The y components, well, that's just a stepping stone to find something. But again, once you have your FBD, what's the FBD equation? Is the acceleration 0 in this case?
No,
How do you know?
because we're starting from rest and we're going down the plane.
It reached the bottom of the ramp. It started to accelerate down, right? So then when you put your equation here, net force is equal to Fgx minus Ff, right? And your y, Fn, equals Fgy. You know net force is 0 on the y component. So you can go straight to putting that. Okay, what are you looking for? How long does it take? You're looking for time. How do you get there? That means that you need to find the acceleration. Okay, you need to find the acceleration first. All right, so let's expand. So you've got your FBD. Expand on this. What's net force along the x? MA equals mg This is your 12 degrees right there. mg, fgx is right here. Opposite over hypotenuse. So mg sine theta minus frictional force. Do we know the frictional force? No, we don't. Or do we?
Yeah.
We know the mu. We just know the mu. We don't know the frictional force. So I'm going to just put mu f of n. Okay? And look at that. You know that f of n is fgy. So now you're going to go mg sine theta minus mu. By the way, fg is always mg, right? So how do we expand on the fg of y? That one there. Adjacent, hypotenuse. mg cos theta. So this will become mu mg cos theta. That one is that fn right here. See the connection? Okay. And this is your ma. Now, can we simplify this? If I just want the acceleration, is there a way that I can go straight and finding the acceleration right now? I can do this two ways. I can right away cancel all the m's, and then that will give me the acceleration straight out. Or you can find the net force, which is ma, okay, and then find the a that way. 2 steps, 1 step. I'll go with 1 step if I could do it, right? So there you go. So you now have your acceleration. Just putting in your values now. G, 9.8. So G sine of what's our angle? 12 minus what's the mu? 0.1 times G. I'm just going to put G right there. Cos of 12. This is now calculator work. Once you have your acceleration, 2.05, 2.04 meters per second squared. Could somebody confirm, please? Somebody confirm. So once you have the acceleration, what else do we know? We know that v1 is 0. I'm looking for time. Now I know the acceleration is 2.04 meters per second squared. How do I find the time? When the d is given. This is when and only until here that you take your kinematics equations and pick your proper equation here. And what comes to mind is d is equal to v1t plus 1/2 at squared. Now you go, how do I know what equation to pick? Because that is what you're given. You've got the v1, you've got the d, and you've got the a. And look at this. You see the v1 is 0. That's gone. Cancel it right away. So you have d equals 1/2 at squared. And now you can isolate the t. T is equal to 2d over a square root. And we are done. So 2 times 15 divided by 9.8 square root. Oh, sorry, it's not 9.8. So is it 2.04?
Yeah.
I was still in the projectile motion mind here. So 2.04, is that correct?
I'm like, I get it like in another way, which is like, what I did was 2.4, but I don't know, like this, it comes like minus 14, stuff like that. And I did the whole thing in my calculator, something else.
Okay, I'll take a look. Let's finish this off first. Okay, what's the time? So 2 times 15, so 30 divided by 2.04 and then square root that. Your answer should be, I got 3.83. Let's confirm the 2.04. What it?
Yeah.
Okay, so that's why I asked people to confirm. What is it?
I lost it, but I got a different one.
Oh, well, then you should, okay, you should always say that. If you got a different one, you should always bring it up. So when you confirm this, it's not 2.04. What is it? 1.08. Okay, so 1.08. Now let's plug it in. Divided by 1.08. So 30 divided by 1.08 and then square root that and you get 5.27 seconds. So it's going to take a little over 5 seconds to go down that inclined plane.